Guys, let's do this problem right here. So basically the question is asking using L'Hopital rule evaluate the following limits if they exist. And the question is limit x approaches 0 sine x to the power of x. So we have to find out whether the limit is existing, right? So to do that, so since they are asking for L'Hopital rule, so basic thing about the L'Hopital rule is it's only usable when we have the situation where it is indeterminate, something is indeterminate, right? So in this case, what we have to do is like a sine. Let's directly apply the 0 and let's see what happens. So if I apply 0 for this one, sine 0 is what? 0. Sine 0 is 0. And 0 power 0, what the hell is that? So we don't know what is it, right? So since this case, what I have to do is I have to find a way to get this function. So let's say this is y is equal to sine x power x, sine x power x. So what I can do is I can take ln in both sides to make it a simpler form. So let's say ln y is equal to x. So if I take the ln right here, it's going to be ln sine x power x. So if in this case I can bring this x to the front, and that's gonna basically become like x ln sine x. So x ln sine x. Now let's bring it to the limit. So if I take the limit, so limit x approaches 0, and we have x ln sine x, and if I apply 0 for this one, x is going to be 0, and ln sine x, so ln sine x, sine 0 is going to be 0, but ln 0 is going to be a negative infinity. So therefore 0 multiplied by negative infinity, a case where it's indeterminate. So therefore we can't directly solve it, we have to do something about this. So let's see what else we can do. So if I do limit x approaches 0, in this case, instead of writing this one on top, I'm bringing this one down. So ln sine x over, I can also write this x as 1 over x. It's same thing, because this is this is flippable, like you can bring it to the top or like bottom, it's same thing. In this case, if I apply 0, let's see what happens. So if I apply 0, it's going to be negative infinity over this one is going to be 1 over 0 is going to be infinity, so negative infinity over infinity are still indeterminate form. So we can't really do anything about this. So what we can do is now we can use a L'Hopital rule to find out what we can do. So according to L'Hopital rule, what does it say is, if I find the derivative, I can solve this equation. So if I find the derivative of this one is going to be ln sin x. So derivative of this is going to be 1 over sin x, and this is outside derivative. Since this is combined with the ln, we have to use the chain rule. So this is outside derivative, and this inside derivative is going to be derivative of sin x. Everybody know what is derivative of sin x. It's cos x, right? So cos x, and 1 over x is going to be derivative of 1 over x is going to be minus minus so if I bring it to the top, it's going to be minus 1 x minus 2, so I can write it as minus 1 over x square. So this is my derivative of this one, and let's apply the this limit of 0, and let's see what happens. So in this case, so let's see, let's rearrange this one a little bit, make it a little bit let's make this one a little bit nicer. So let's say x approaches 0, 1 cos x over sine x minus sine x, and I can bring the x square to the top, so it's going to become something like x square, and let's say this is minus sine x, right? And if I apply 0 right here, 0 multiplied by cos x, cos 0 is 1, so 0 multiplied by 0 is going to be 0, 0 and sine 0 is going to be 0, so still an indeterminate form. So we had to choose one more L'Hopital rule. So one more, let's see one more L'Hopital rule and what happens. So limit x approaches 0 and x square is going to be 2x times cos x, derivative of cos x is going to be minus sin x over now minus x sin x become cos x. So 2 times 0 is going to be 0. 0 multiplied by, this is going to be a 0, 0 minus 0 is still a 0. So, see, this is multiplication, right? So this is multiply 0, still a 0. And cos x divided by cos x, cos 0 is going to be, cos 0 is 1. So now we can solve this one. So this is going to be equal to limit x approaches 0 and 2x is 0. The I can directly substitute instead of writing the limit. So let's raise this one and put the 0 for x values and see what happens. So if I put the 0 for the x1 is 0 minus 0 multiplied by minus 0 is going to be 0, 0 over 1. So which is going to be 0. But we are not done yet, because if you see the value we could getting is ln y, but the real value should be for the 1, right? So if ln y is equal to 0, ln y is equal to 0, so what is the value of y? So to find the values y, what should I do is I have to eliminate this ln. The only way to eliminate this ln is to take the e power both sides. So if I take the e power this side, it's going to e power ln y, and if I take the e power other side, it's going to e power 0. In this case, here the e and ln will cancel each other. Therefore, this will become y is equal to e power 0. We know e power 0 is equal to 1. Therefore, y is equal to 1. This is the final answer. And that's how we solve this equation. I hope you guys understood this concept. See you next time.